Hello viewers, let me welcome to this session of discussion. In the last session, we have defined Coulomb's law in electrostatics, which is an empirical law and based on some experimental observations. And the mathematical formula for Coulomb's law is already given and is given by F is equal to beta times Q1 Q2 by R square, marked equation 1. This equation gives you to calculate the magnitude of force of interaction between two point charges Q1 and Q2 separated by distance R. And beta is a proportionality constant which has already been discussed. Now to write equation 1 in vector form, some vector relations we should know, and these are discussed in the diagrams. Let Q1 and Q2 are 2 point charges placed at the points A and B respectively. The position vector of Q1 is measured from O and is directed in the direction OA, which is given by R1 vector. Similarly, the position vector of Q2, which is directed from O and is given by R2 vector, that is OB vector is equal to R2 vector. Now let us calculate the force on Q2 due to Q1 given by F21 vector. So the position of Q2 should be known from the charge Q1 and it is measured in the direction AB vector. And the AB vector is given by the vector relation OA vector plus AB vector is equal to OB vector, implies AB vector is equal to OB vector plus minus OA vector is written as R2 vector minus R1 vector is equal to, is written as R21 vector is equal to R21 into R21 cap, where R21 is the magnitude of R21 vector and R21 is the unit vector given by R21 vector divided by R21. Similarly, to calculate the force on Q1 due to Q2, the position of Q1 should be known from Q2 in the direction BA vector, and BA vector represents the position vector of Q1 relative to Q2 and is related by the equation OB vector plus BA vector is equal to OA vector, implies BA vector is equal to OA vector minus OB vector is equal to R1 vector minus R2 vector is written as R12 vector is equal to R12 into R12 cap, where R12 vector mode is the magnitude of R12 vector, that is R12, and the unit vector R12 cap is equal to R12 vector by R12. The unit vectors R21 cap and R12 cap show the direction of R21 vector and R12 vector respectively. Hence, from the two diagrams 1 and 2, AB vector is equal to minus BA vector implies R21 vector is equal to minus R12 vector. But also R21 cap is equal to minus R12 cap because both are in opposite directions. So AB vector mode is same as minus vector mode is equal to R21 vector mode is equal to minus R12 vector mode is equal to R. This is the simply the distance separation between 2 point charges Q1 and Q2 and which is equal to AB. Now using these relations, let us now calculate the force on Q2 due to Q1 and also force on Q1 due to Q2. Let us take case 1 where Q1, Q2 greater than 0, that is both charges are positive, or Q1, Q2 greater than 0 where both charges are negative. Since both charges are positive or both charges are negative, the force that exists between the 2 point charges is repulsive, and this repulsive force, that is Q2, is repelled by the charge Q1 in the direction AB vector and which is in the direction R21 cap or R21 vector. So this is represented by F21 vector, which is given by F21 vector is equal to beta times Q1 Q2 by R21 square into R21 cap is equal to beta times Q1 Q2 by R21 cube into R21 vector. This is shown in figure 1. Similarly, the force on Q1 due to Q2 is also repulsive and it is directed in the direction of BA vector, that is in the direction of R12 cap and is represented by F12 vector, and F12 vector is given by beta times Q1 Q2 by R12 square into R12 cap, which is equal to beta times q1 q2 by r12 cube into r12 vector. This is shown in figure 2. Now, since r21 cap is equal to minus r12 cap, or r21 vector is equal to minus r12 vector, because they are in opposite direction as shown in the diagram. So using equation, these relations in equation 2 and 3, we have f21 vector is equal to minus f12 vector is equal to f21 vector is equal to implies mod of f21 vector is equal to mod of f12 vector is equal to f21 or f12 fe. So this is these are the magnitudes of the force of interaction between 2 points q1 and q2, which is given by beta times q1 q2 by r21 square is same as beta times q1 q2 by r12 square is same as beta times q1 q2 by r square. That this is equation 4. Now you see f21 vector is minus f12 vector, but the magnitudes are same. This shows that the force of repulsion are equal in magnitude and opposite direction. That is, q2 experiences the same amount of force that q1 experiences, but they are in opposite direction. Magnitudes are same, direction is opposite. Let us take case 2, where q1 is greater than 0, q2 is less than 0. That is, q1 is positive, q2 is negative, or q1 is less than 0, q2 is greater than 0. That is, q1 is negative and q2 is positive. Since both the charges are of opposite sign, there exists a force of attraction. That is, q2, the charge at B, which is minus q2 or plus q2, is attracted by the charge placed at A, that is either q1 or minus q1 as shown in the diagram. So these attractive forces are given by f21 vector and f12 vector, and since the charge at B is attracted towards charge at A, so it is represented by f21 vector, and this is in opposite direction to r21 cap. Similarly, the force on q1, the force on the charge at A due to the charge at B is also attractive, is represented by f12 vector, which is equal in opposite direction to r12 cap. So these are represented by the equations f21 vector is equal to beta times q1 q2 by r21 square, and this is directly in opposite to r21 cap, so it is given minus r21 cap, which is same as beta times q1 q2 by r21 square, which is r12 cap, because r12 cap is negative of r21 cap. And similarly, the force on q1 due to q2 is given by f12 vector is equal to beta times q1 q2 by r12 square into minus r12 cap, because f12 vector and r12 vector they are in opposite directions, and since minus r12 cap is equal to r21 cap, so it is beta times q1 q2 by r12 square into r21 cap. That is, f21 vector is the direction of r12 cap and f12 vector is the direction of r21 cap. That is, both the forces are equal in the, using these two relations. We have 5 to 1 vector is equal to minus 5 1 2 vector. F21 vector is equal to minus f12 vector, but the magnitudes are same. That is, even if the force is attractive, they are also in opposite direction and are directed along the line joining the 2 point charges. So equation 2 and 3, equation 5 and 6, these are the relations written in vector form. These are nothing but Coulomb's law of interaction between 2 point charges, and this shows that even if q2 is greater than q1 in magnitude, or q1 is greater than q2 in magnitude, or q2 is positive or q1 is negative, or q1 is negative, q2 positive, whatever may be the cases, each charge will experience same amount of force, the magnitude is same and direction is opposite. And this is what is the vector relation, this is the vector form of writing Coulomb's law. So let us stop here. Thanks.